Hi students, I'm Dr. Seema Singh and you are watching my channel Bonding with Chemistry. In my previous videos on this chapter, I have provided you general introduction of acids, bases and salts followed by a detailed explanation of various types of indicators. In my last video, I had defined acids and bases according to Arrhenius' concept and helped you learn what exactly is common to all acids and bases. In case you missed out on any of these videos, you can always go to the serial-wise links provided in the description box below. In today's video, we'll classify acids and bases and understand the dilution process. I did say in my last video that I would be taking up pH scale too. But my dear students, it being a very important topic, I thought of taking it up exclusively in my upcoming video along with importance of pH. So stay tuned and hit the bell icon for latest updates on my videos. Let us get started with classification of acids. Acids can be classified on the basis of strength, composition, and concentration. There are few other ways of classifying them too, but you would come across them in your higher classes. In this video, I'll be taking each one of them in detail. To begin with, acids can be classified into strong acids and weak acid depending on their strength. But what exactly we mean by strength in case of acids? Strength implies the degree or the extent of ionization of an acid. For example, if you dissolve HCl in water, it is going to furnish proton or hydronium ion and the corresponding anion. Here it is chloride anion. Since acid furnishes hydronium ion or proton in water, so we measure the extent or the degree of ionization of an acid in an aqueous solution. Greater the number of protons or hydronium ion furnished by an acid, stronger it is and vice versa. So we can define strong acid as those acids that dissociate completely into corresponding ions when dissolved in water. With corresponding ions, I mean the proton or the hydronium ion and the corresponding anion. It could be chloride, sulfate, nitrate. It depends on which acid you are taking for measuring the extent of ionization. As far as representation in a chemical equation is concerned, since strong acid undergo complete dissociation in aqueous solution, a unidirectional arrow, just a forward arrow symbolizing a forward reaction is used. Coming on to weak acid, if you have a look at acetic acid, which is a weak acid, when acetic acid is dissolved in water, it furnishes proton or hydronium ion and the corresponding anion, here it is known as the acetate anion. So we say weak acids are those that dissociate partially into corresponding ions when dissolved in water. Since the dissociation in case of weak acid is only partial, so the reaction does not go completely in one direction, that is forward direction. In this case, you will have both dissociated ions or molecules and the undissociated molecules in equilibrium. And thus such reactions are represented by two half-headed arrows. So if you have an arrow, the tail and the head, you have half-head. Two half-headed arrow pointing in opposite direction. These arrows are also known as reversible arrow. If you want, you can show two full-headed arrows. Both are acceptable, but this is more accurate. Most of your mineral acids are examples of strong acid. For example, hydrochloric acid, sulfuric acid, nitric acid. My dear students, please note that these three acids are also known as your bench acids or your shelf acid. This is the common word, bench acid. Now, why are they so called? Because these are the most commonly found acids on your working shelf or bench in your science laboratories. I mean, most commonly used acids. Whereas, if we take examples for weak acid, we find that organic acids such as your acetic acid, formic acids belong to this category. We do have exceptions here. For example, carbonic acid H2CO3, boric acid H3BO3. They are examples of mineral acids, but they're not classified as strong acid. They belong to weak acid. In order to get more clarity on this, let me explain you what are mineral acids and organic acids by moving on to next category of acids, which is based on chemical composition. You can also say it's based on origin or the source. Organic acids, as the name suggests, are found in organisms, living beings like plants, animals, whereas mineral acids, also known as inorganic acids, are obtained from non living sources, mostly minerals that are found in earth crust. Organic acids have carbon and hydrogen as their essential elements. Like acetic acid has the formula CH3COOH. It has carbon as well as hydrogen. Your formic acid is HCOOH. Again, it is hydrogen and carbon. You may also say that they also contain oxygen as an element. My dear children, just a small suggestion. You should keep practicing chemical formulae of simple compounds like acetic acid, formic acid, and others which are part of your syllabus. Because as we move ahead with chemical equations, we would be using more of these formulas. And it should automatically come to you that acetic acid is nothing but CH3COOH. So start writing and remembering these formulas. Coming on to mineral acids, they're composed of different elements. They need not have carbon. For example, you can say hydrochloric acid. It is a combination of hydrogen and chlorine. It doesn't contain carbon. Sulfuric acid has a combination of sulfur, oxygen. It doesn't have carbon. We do have exceptions to this rule. For example, carbonic acid. It has carbon, but it belongs to mineral acid. Now, these organic acids are the ones you come across in your everyday lives. I have talked about this in the introductory video of this chapter. You can go through it by clicking the link provided on the top of this video or in the description box. These acids are present in various food ingredients that we consume. For example, citric acid is present in citrus fruits like lemons, oranges. Lactic acid is found in curd, acetic acid in chow mein, pickles, etc. These acids, as I've already mentioned in my previous slides, they belong to the category of weak acids because they do not undergo complete dissociation in water, only partial. Also, these acids are not classified as extremely dangerous, corrosive, or poisonous acid. Mind it, we are eating them almost every day in various food items. They can pose discomfort when consumed in excess. For instance, if you consume pickles, lemons, or tomatoes in excess, you might develop blister on your tongue or at most suffer from acidity. But we cannot say the same for mineral acids, which are highly corrosive in nature. They are poisonous, they are non edible. You can see the various danger signs on bottles of these acids. They are so dangerous that, God forbid, if they fall on your hand, they have the power to burn or simply melt your skin and destroy the flesh, muscles, and reach your bones. I've told about all this in my introductory video. So you have to be very careful when using them and never ever taste them. You might ask that concentrated HCl is present in our body, yet it does no harm. My dear children, that concentrated acid, as you will study in biology class, is protected by an inner strong mucus lining of stomach. If it reaches any other part of your body, such as your food pipe, esophagus, which actually it does during acidity, you do feel the burning sensation. Again, we do have exceptions in this category of acids too, like carbonic acids, H2CO3. The formula should come automatically to you now. Now, this acid is present in most of your cold drinks. Your apifiz contains this. In fact, this carbonic acid is responsible for that fizz. You also might have touched boric acid powder as an antibacterial cream, or more commonly that white carom powder sold in market, which let your striker glide smoothly on the board. I personally don't find children playing carom anymore. Guess that's the study pressure. But I feel mobile phones and gadgets have killed our beloved carom. Anyway, let us move on to the next classification of acids based on concentration. In chemistry, concentration of a solution means the amount of solute that is present or dissolved in a given amount of solvent. The more is the amount of solute, the more concentrated a solution is. And if the amount of solute is less, the solution is said to be dilute solution. Let me explain you with a simple example. You must have come across a bottle of orange squash or ruafza in your kitchen shelves or refrigerator. Now, do you drink that squash, which is a thick syrup kind material, directly? The answer is no, because you say it is so thick, sticky, and extremely sweet. You mix it with water or dilute the squash by taking a small quantity of it in a glass and pouring water to it. So you diluted the concentrated solution. Diagrammatically, let us take two beakers and add 100 ml of water in both. In first we pour 20 ml of orange squash and stir it, and in second we add 60 ml of orange squash and stir it. The first solution is an example of dilute solution, whereas the second one is a concentrated solution. Now dilute and concentrated are relative terms, they're comparable terms. What does it mean? Suppose I take another beaker with 100 ml of water and add 40 ml of orange squash to it and stir it. Let me label the first one as beaker number 1, this one as second, and this one as third. Can I say the solution in beaker number 2 is concentrated with respect to 1, whereas with respect to third, it is a dilute solution? Thus the meaning relative. Now coming on to concentrated and dilute acids. Here, your acid is the solute, whereas water is the solvent. We say a given solution of acid is concentrated when the amount of acid dissolved is relatively large as compared to the quantity of water, whereas when the amount of solute is small as compared to the quantity of solvent, we get dilute acids. In a chemical equation, if need be, we represent a concentrated acid with the abbreviation CONC written in parentheses, that is bracket, on the right of the chemical formula of the acid. Whereas for a dilute acid, we use the abbreviation DIL. Students, please note that strength and concentration, though used interchangeably by many, are two different terms. This and this are not same. As far as acids and bases are concerned, strength shows the degree of ionization in water, whereas concentration is the amount of acid or base dissolved in water. For instance, based on strength, I'll say acetic acid is a weak acid. Why? Because it dissociates only partially into hydronium ion and acetate ion. Yet it can be concentrated as well as dilute. For example, let us say we have two solutions of acetic acids, A and B. One of them is 12 molar and the other is 5 molar. Now this M stands for molar, which is moles per liter. It is basically a unit to express concentration. We would study about it in detail in class 11. Now, the first one is a concentrated solution of acetic acid as compared to the second one, which being 5 molar is a dilute solution. But both the solutions are weak acid. They will not dissociate completely into corresponding ions when dissolved in water. Similarly, HCl, on the basis of strength, can I say HCl is a strong acid because it dissociates completely in water? But if you have two solutions of HCl, one is 2 molar, the other is 1 molar, we say this one is concentrated solution of hydrochloric acid as compared to this one, which is a dilute solution. Remember, HCl is highly corrosive, and if it is concentrated, it is all the more dangerous. Don't worry, in lab for your class level, you would deal only with dilute solution of acids. Now, how this dilution is done? It is very important for you to understand the dilution process. But before that, let us quickly go through the topic classification of bases. Just like acids, bases can also be classified on the basis of strength and concentration. We do have other classifications, but that is not in your course. Based on strength, we have strong bases and weak bases, and based on concentration, we have concentrated bases and dilute bases. Let's begin with the first type of classification. Now, a strong base, just like your acid, dissociate completely into corresponding ions. Since it's a base, so it's going to dissociate into hydroxide ion and the corresponding cation. Here it is sodium ion. If it would have been potassium hydroxide, it would have been hydroxide and potassium ion, barium hydroxide, hydroxide and barium ions. Greater the number of ions that are going to be dissociated, the stronger your base will be, and vice versa. Whereas a weak base dissociates partially into corresponding ions, and thus it is represented by two half-headed arrows pointing in opposite direction or your reversible arrows. Example of weak bases are ammonium hydroxide, magnesium hydroxide, remember milk of magnesia, your copper hydroxide. Whereas for strong bases, we have sodium hydroxide, potassium hydroxide, barium hydroxide. Moving to the next classification, based on the amount of base that is going to be added in a solvent, which is going to be water, we have concentrated bases and dilute bases. If the amount of base is more as compared to the solvent, we get concentrated bases, and if it is less, we get dilute bases. If you look at the representation, concentrated bases are shown by abbreviation CONC against the chemical formulae of the base, whereas dilute with the abbreviation DIL. Dear learners, you would have noticed that we have taken water as a solvent in case of both acids and bases. This is because an acid or base will show their respective nature, their acidic or basic nature, only in presence of water. For a detailed explanation, you can always go through my last video, whose link is provided both on the top of this video and the description box below. Just as I have explained for acids, your weak bases too can be concentrated or dilute. Similarly, your strong bases can be also concentrated or dilute. Let us move on to the dilution process. Suppose you have to mix acid and water, and I ask you a simple question. Will you add acid to water or water to acid? Well, you might use or recall your experience from everyday life, say preparation of lemonade or orange squash, and might answer it doesn't matter. Most of us add squash and then dilute it with water. Some of us may take water and then add squash to it and stir the solution with a spoon. In both cases, squash is prepared. The only difference being the first gives us a better idea about the quantity of squash and hence its sweetness. But my dear children, this is not true in case of the dilution process. You must always add acid to water and not vice versa. I repeat, this is the correct procedure of dilution, whereas this one is the incorrect procedure. Before we understand why so, let me tell you a simple mnemonic to remember this dilution process. That means you're going to add acid to water. It might look very simple right now that it is easy to remember that you're always supposed to add acid to water. But I have seen students getting confused if a question is asked in say viva voce or your theoretical examination. The simple mnemonic is A comes alphabetically before W. So it is always A to W and not vice versa. So you remember A to W? Isn't it similar to your Amazon symbol? You must have witnessed this on your online shopping site, Amazon, that you can find anything and everything on Amazon from A to Z. Similarly, A to W, because you will have two things, acid and water. So alphabets you already know. A comes before W and add it. I'm repeating this because it is very, very important that you always add acid to water and not vice versa. Let us now understand the dilution process. The dilution process, which is mixing acid and water, is highly exothermic. That is, a lot of heat energy is released when the two, acid and water, are mixed. This heat might cause accident during dilution process. Let us see how. Suppose you take a beaker containing acid in it. Now, in order to dilute this acid, you add water to it with the help of dropper. You would see that a lot of heat fumes are released the moment water touches the acid. The heat evolved is so high that it may lead to splashing of acid droplets. These droplets may cause burn injuries and may even break the glass container, leading to an accident. My dear children, never ever try this, not even for fun. Do not. Whereas, when an acid is slowly added to water, the heat released is absorbed by water as it is a good absorber of heat, and thus splashing of liquid is avoided. You will read in higher classes that water has a high specific heat capacity. Thus, dilution process must be carried with caution and patience. It definitely requires time. So you're supposed to carry out slowly. Add the acid slowly to water with constant stirring. If in case the beaker gets heated up, wait for some time and then continue the process. I'm sure Now you would be able to answer this in-text reasoning question with ease. In case you get stuck up, you can always look at the answer provided. Coming on to another reasoning question, which says that how is the concentration of hydronium ions affected when an acid is diluted? You know that when an acid dissociates in water, it furnishes hydronium ion and the corresponding anion. When you're going to dilute it with water, the quantity of water is going to increase, but the number of hydronium ions per unit volume would reduce, and hence we can say the concentration of hydronium ions would decrease. Let us take up another similar reasoning question, which says that how is the concentration of hydroxide ions affected when excess base is dissolved in solution of sodium hydroxide? That means you already have a solution of NaOH and you are adding more base. So if you are adding more base, it will furnish more hydroxide ions and thus the concentration of hydroxide ion would increase. With this question, I come to an end of this video. In my next video, I'll take up a very important topic, the pH scale and its importance. So if you have yet not subscribed to my channel, make sure you do it now. Also, if you like my video, do give it a thumbs up. And for latest update on my videos, hit the bell icon. That's all for now. Thanks for watching and stay bonded, my dear learners.